Hi everyone, this is Mr. Tukin, and I want to thank you for taking a peek at the 7.02 tutorial video. If you pay attention to this, you're literally going to be able to go to the 702 assignment, and the problems we work on here are identical to them. We're going to have some different numbers that we use here, but you can use those different numbers and apply them in the same ways I do here in this tutorial video. And if you stick around at the end, you'll also get some information on how you can earn collaboration credit just by watching this video. So what I've already typed out over here is an example of an exponential function, and you can notice we've got this word bank of different stuff. So we did kind of go over real quick that the a is a variable. Whatever value is there, it's said to be the initial value, um, and the principal, or principal is kind of another word for starting value. So just a heads up, a is both the initial value and the principal that you've got going on there. You've got the value of b, and whatever b is, that is said to be, well, base. It's also your multiplier. Sometimes when we see the value that something's multiplying by, that's the value that's going to go there. When you have exponential functions, there's definitely this multiplying thing going on. So if we look, the only other thing in this word bank is, for the most part, the variable x is some type of reference to time, how much time has passed, whether it's usually it's years, but it could be some other number or value. So we express it in usually years, but time is what x is going to be looking at. So think about it. If we have the word initial value where we start at, principal is also kind of a starting point. Sometimes even though it's not on here, it's also like the y-intercept on a graph, but we don't have to worry about with the examples we have to work on. So we've got this example project that you're going to be working on, and they talk about these different people and some of their situations. In this case, like Harrison, Anita, Juan, and Krista. And you can read this description. Harrison shared her video with 5 friends, and the friends continued to share it, doubling the number each day. And this is an example of an exponential function that represents this. Well, remember, if a is your initial value or where you started, that's the 5 people. And since it doubles, that's a multiplier. We're doubling something. That's multiplying by 2. That's our multiplier. That's going to be our value of the base, which is why we see it as 5 times 2, although this isn't exactly up enough. It should be x up here. That's the volume for, or excuse me, the exponential function that represents Harrison. If we go on, a lot of the times they're going to ask you to create the exponential function for the people we don't get them. So just reviewing Krista real quick. Krista shared her photo with 8 friends. She's starting with 8 people. That's an initial value. And each of them shares it with 3 other friends. Well, if each friend, each is usually a word that kind of means, hey, we're multiplying something. If each friend shares it with 3 and they continue to share it from there, then you're going to get it multiplying itself over and over again, and that's where the 3 comes from. So you can see 8 times 3 to the x power. Again, that x should be raised up. It's not really typed right here. But those would be the exponential functions for Krista and Harrison. So one of the first things you're going to need to do on 702 is create the exponential functions for the one we weren't given. And they'll actually express it in a couple different ways. Anita shared her photo with 42 followers. Each of them shared it with 2 more friends, doubling the number of viewers each day. So just like before, we've got the value that's going to tell us, okay, for Anita's function, and if you want to use g of x or h of x, if you want to use different function notation, which that's all that is, that's fine. You want to figure out how much do they start with? Well, their initial value is 42, right? You started out with more people, and you're going to double it. So if we're doubling, again, that's a multiplier of 2. And that's raised then to the x power. We want to make sure we're throwing that up there. That's a good one for Anita. You also can see the multiplying if you look here. Notice that's doubling. That's multiplying by 2 each time. You can kind of see it in a chart view of what Anita is. And in this one, they just kind of restate the same thing over and over again. Juan shared his post with 3 friends. And I'm going to say for Juan, I'm throwing up g of x, just a different function notation. And then they shared it each with 3 friends. There's that word each, which means multiplier. So yeah, he's starting out with a lot less friends, but his multiplier is greater. each friend's sending it and sharing it with another 3. So that's where we're going to create that exponential growth because, yeah, we start out small, but if each one's sending it to 3, we're eventually going to get more and more people involved. We're going to get more and more shares on the post, so to speak. So that's how we can create and pull out the initial values for each one of them. And we can see that in this one that we created. This is just walking through A, or number 1 on the assignment, which we already did. And then it said, hey, for number 2, get that same thing with Juan, which we created here. Now remember, on your assignment, you're going to have different scenarios, but you can attack it the exact same way. Okay? We want to predict how many shares they will have on day 3 and day 10. So remember, that's our time value. That's how much we have in time. So if we come up here, we are literally going to plug in these values and show the math work on the assignment. So when we're looking at something like this one, and they want us to figure out on day 3 and day 10, we've got that value of x, which is x represents the amount of time. So if we are working on Anita's example, we're going to use her function from below, which was 42, then parentheses, 2 since it was doubling, and we're going to go ahead and we're going to evaluate it when it's 3 days in, and we'll also evaluate it when it is 10 days. So we would, for the 10-day one, same thing, but instead of 3, we are going to use 10 as the exponent. And this is where what we'll do is we'll go in and we'll grab our calculator and we'll kind of evaluate these based on those values. Remember, you do have to do the exponent part first and then you multiply based on order of operation. You will need, if you're using a calculator like mine, you have to switch it from standard to scientific if you're using it on a Windows computer. So we'll start out by just simply trying to figure out what is 2 to the 3rd power. Now that's just 2, and actually on the calculator, if you're using this one, you got to type the number and then this, and that's going to tell it that, okay, 2 is the base, and then the next number you enter is the exponent. And if you hit a equal, it will tell you 2 to the 3rd power is 8. And that's the same as saying 2 times 2 times 2. Obviously, that's a lot easier to do than 2 to the 10th. So that's why I did it this way. But we basically would have at this point 42 times 8. And if we do 42 times 8, we get 336. So this is the work you will show to kind of answer when you're trying to figure out how many on day 3. You take the function you created and then you plug it in and evaluate it, remembering to do the exponent first. So if I clear this out here and we simply do it again, but this time we're going to use that base of 2. We're going to hit that button and now we're going to use 10 because it's the exponent of 10. That's 1024. And so if we take 42 times 1024, that's going to give us our number of shares after 10 days have passed. So we end up with 43,008. And remember, your problem will be the same steps for Anita, but it will be with different numbers because the numbers on the actual assignment are different. We're going to repeat that for Juan. Now Juan's function, as we remember from earlier, is we've got the 3 to the 3rd, 3 times 3 to the x power. So when we plug in for that under Juan, we've got that 3 times 3 again to the x power, and we're going to do the exact same thing like we did before. So we're going to plug in at day 3. So a lot of 3's for Juan in this example. We're going to get 3 times 3, all of it to the 3rd power. Now, again, you can go into the calculator. I do know that 3 to the 3rd power is actually 27 because 3 times 3 times 3 would give us 27. And then we just do that by 3 again. So if we have 27 times 3, maybe you can do it in your head as well. But just to double check, we're going to end up with 81. And then we're going to go ahead and do it again. And I'll just do it side by side this time. We have 3 times 3, but this time we're going to raise it to the 10th power. And if I do that, I'm going to come down here to the calculator again. I'm going to clear it. We're going to go ahead and do 3, then this little button, and then I enter the exponent. And that gives us, a very big number. So we're going to end up with 3 times 59,049. And we multiply that by 3 again. So we can see that when we compare these two, early on, we can see something. You know, Anita had more initial people, but her multiplier, the 2, was not as high, excuse me, as even just Juan's, which was 3. Yet, because this is exponential, it kind of explodes on us. And we can see the effect the longer the days go on. Look at how after 3 days, Juan still has not caught up to Anita, but by the time we get to day 10, where Anita had 43,008, look what happened to Juan. His number of shares, because his multiplier was greater, creates that exponential growth, which over time Juan will surpass Anita. And that is actually the last question that comes up when we look at these answers and stuff. Um, the last question will actually ask you, who do you prefer and why? Well, if your goal is to get the most shares, that's where the talking about the multiplier being the most important thing. So we can actually come back to the original question and you can kind of look at everyone's. All right. Well, if we're actually comparing all 4 people, in this case, Juan and Krista will have the same multiplier of 3. So since Krista's is had more people to start with, hers will ultimately be greater than Juan over the long run. And same thing when comparing to Anita and Harrison, because again, the biggest factor is multiplier. If we go multiple days out, eventually Krista's is going to get the most shares. All right. So that's how we kind of attack this one. And if you did watch this, you now can try the assignment on your own. Maybe you go back, watch it again, pause it, and you can do question by question with my examples. However, by watching this, you're going to get collaboration credit as well. So once you turn in 702, you can go to the S2 collaboration, which is an assignment at the end of the second segment, literally the last assignment. And in the comments of that, you can say that you watched the 702 recording for helping completing the assignment. And if you literally answer this one question, you're going to get 20 points credit for that assignment, the S2 collaboration, which is basically how can you use some of this stuff in a real world situation. Feel free to Google search exponential functions in the real world to finish the question. Sorry, that got caught off there. But you do that, you get the 702 credit. You're going to get the S2 collaboration credit as well. So hopefully that helped. Thanks.